Hello everyone. So in today's video I want to talk about something that I haven't really talked about before, and that is the concept of numbers that are larger than infinity. So of course there are going to be some people that think I'm crazy because, infinity in the traditional mathematics, infinity is seen as the largest possible quantity. And yes, while that is true, there are concepts of types of numbers that are, in fact, larger than infinity, if you will. So, I'm going to take a simple example. Hold on, let me just edit this real quick. Okay, so suppose that you have, of course, this is natural apples, of course, natural numbers. Natural numbers, suppose this set of apples. So we have the first apple, second apple, third apple, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on forever and ever and ever. Well, of course, that is going to continue on forever and ever. However, this would equal a result of, sorry guys, Aleph 0. So you're probably going to think, what the heck is that? Aleph 0 is the amount on how, oh, whoops guys, sorry about that. The amount of natural numbers there are. So we have that, and of course that this is Aleph 0 is an infinity. See, here's the problem. People get mixed up with the fact that people think that infinity is in the set. Infinity is not in a number set or anything whatsoever. It's actually outside of it. You see, the reason why we don't consider infinity as a number is because it surpasses every number. And I can even show this. So suppose that you have 1,000,000,000,000 apples in this set. Of course, that's a finite number, meaning eventually, once you, after a large amount of time, you're still going to reach its end. Infinity, however, is the concept of something that is so unbelievably vast that it literally cannot even be, it cannot be counted or limited by any known standards, by anything. And what that means is, so basically infinity is a concept of something that has no end or boundaries whatsoever. And that's what it is. Infinity is a concept of a amount that surpasses every possible number that there ever was or ever could be. So that's just infinity. However, we have the real apples down here. So we have 0 and then 0.000. However, that line of zeros will continue on for an infinite number of time, meaning that you could always keep on having more zeros. And then, of course, this. So this, you might be thinking, okay, well, simple. It's the real numbers is the same as this, but we can't do that. You see, the problem is in the natural numbers slash apples, if they're not apples, but we're just taking that, but based on what I've typed, there we can easily we could get to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we can just keep on going. No big deal. The real numbers slash apples go on. You can't just skip all of that and then just move on to the next integer. You actually have to count on how many digits slash zeros there are. So we have 0, and then we have 0.00000000000, and the zeros will continue on forever, an ever expanding amount of time. And that's just a little example. And then of course we have this. This would be like pi or something like that. But the point is that you see this. So this equals Aleph 1, which is the amount of real numbers there are. So you're probably thinking, okay, simple. How much is this? Well, prepare to have your minds blown. The amount on the number on how far the distance between Aleph 0 and Aleph 1 is so unbelievably mind-bogglingly impossibly off the scale big that we can't even consider it near each other. Like, we literally cannot even quantify this. And this this can also be called, mathematicians seem to call it this. This can be called uncountable. Oh, whoopsie. Oh, jeez. I'm having a rough start today. Okay, there we go. Uncountable infinity. And that, you get the point. However, if we take we're gonna do something. You see, we can also take the idea of the surreal numbers. Of course, I'm just typing apples because that's what we're going based off of. But you see, the amount of surreal apples is crazy. It's crazy big. And then this could just keep on going. And so here's an example. The amount on how, so we have the natural numbers. You see, the natural numbers is obviously 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then so on. This set equals Aleph 0, or which is countable infinity. The amount of natural numbers there are. That's how many. Aleph 0 is how many possible natural numbers there are in the set. The real numbers, or apples, this set equals Aleph 1, or also known as countable infinity, or even the continuum. This Aleph 1 is the amount on how many real numbers there are. The surreal apples are much. I can't even describe. Here's just an idea. The amount of surreal apples that there are possible is so big that not even, basically, I don't know this, but the surreal numbers, I don't even know what Aleph number goes into this. I don't even think the Aleph numbers go into it. By the way, I only know just a little bit about this kind of stuff, so of course I'll just have to look up more knowledge on another video that might come up. But anyways, the amount of surreal apples is much more mind-bogglingly, uncountably, infinitely larger than both the natural apples and the real apples / numbers, of course. But yeah, that's pretty much it for this. If you want me to make a part 2, I'll gladly do it. So anyways, have a good day, and that's it. Good luck. and have a great day.